Okay, I think it's time to start. We don't have too many attendees today, but I think we should start. Otherwise, we won't be able to finish before 11. And hopefully, we can finish our training within 2 hours. So please bear with us. And there will be not too many commands or tricky things for you to understand. So hopefully, if you're able to access to a Linux box while I'm typing those commands, you can follow me and typing those commands. And since we don't have too many attendees, if you have questions, don't understand, feel free to interrupt me during the training so that I can give you an explanation. All right. Okay, so this tutorial topic is basic shell scripting. And this is the 4th training session of the semester. I saw some of you are in our previous trainings. What do we have talked about in the previous trainings since January? We talked about introduction to Linux. We talked about HPC user environment 1 and 2. So let's first go do a very brief overview of the things we have talked about so far. The whole purpose of our training is help you to better utilize the resources, better utilize the HPC resources. So it's not meant for you to help you pass any hard interview questions for those big companies like Google and Yahoo. No, our training is not meant for that. Our training is meant for you to use the cluster, better use the cluster, and how to use it efficiently. And most of you here are either graduate students, postdocs, professors doing research. And our purpose of the training, the materials we're using are tailored to help you do research using our clusters. And the introduction to Linux, because all the clusters are using the Linux operating system. So if you have never used the Linux system before, and those slides, those materials, provide the fundamental materials for you to have a basic understanding of Linux. And basically what we teach in those materials are how to navigate through the file system, how to access files, how to open files, how to navigate you through the different directories, and including file permissions. And those are the primary purpose of introduction to Linux. User environment 1 tells you the policies of using HPC and Lonely clusters in our environment and how to access it. And what did we talk about last week? As most of you here, what did we talk about? That's actually the most important part of our trainings, how to submit jobs, right? And there are basically 2 types of jobs you need to submit. What are the 2 types of jobs we use to submit our jobs? One is interactive and one is batch. The interactive jobs are used to do some trial and error things for your tasks. If you have a job that has never run on HPC, and if you run a batch script, it might give you lots of errors, and using a batch job will be inefficient. And after you're comfortable with running your tasks on our clusters, it's better for you to write a batch job script so that you can have lots of production runs on our cluster. And that's the efficient way of running your production jobs. If you run your jobs with like 10, 20 nodes, even 100 nodes, and you need lots of communication, you need lots of computation intensive tasks, and it takes like 3 days to finish, and those jobs need to be submitted in a batch job. And following that last week's training, we will have today's basic shell scripting. That's actually help you to how to write your job scripts. If you have a relatively complicated control flow of your jobs, and this tutorial is meant for you to how to schedule your different tasks, your different commands efficiently. Still, the material can be applied to your general Linux workflow in your daily work. If you're using Linux for your daily work, you can still use the same fundamental knowledge to do your things, do your tasks. But the primary purpose is to give you a basic understanding of the programming, how to programming a shell script, right? So there are no very difficult things. So let's give an outline of today's training. 1, 2, 3, 4. First, we give you a very brief overview of Linux shell, give some basic or fundamental knowledge, basic introduction. And those are necessary introductions for you to get started with the basics of shell scripting, which are our second part. Our second part is the basics of shell scripting. How many of you have ever programmed a high-level programming language like Python, MATLAB, R, Fortran, C? Okay, at least one of you have ever programmed a high-level programming language. And when you talk about and you start to learn a programming language, what's the first thing you talk about when you have a book of Python or C? You bought it from, you download it from internet, you bought it from bookstore, and what are the first part? What do those fundamental books talk about? Have any idea? They talk about variables. Why all these books has to start from the variables? Because that's how your data are stored. Right? You put your data in a variable, and then what's next? And that's how you operate. You manipulate those data based on how those variables are stored, how those data are stored. That's why how we start learning a programming language. And shell scripting is a programming language. You can consider a programming language that follows the same logic. But it has a different purpose compared to different type of, you can say scientific programming language or other high-level programming language. It's used to schedule a task, schedule commands. So it's different. The logic is quite, not completely, it's kind of different from you using a high-level programming language. And so that's why we need to talk about shell scripting in a separate tutorial. So we still follow the same logic as a high-level programming language. We'll first talk about variables, how to use these variables, how to reference those variables. We'll also talk about arithmetic operation. Basically, that's how you operate those variables. And we will touch a little bit about arrays. So in Bash, I said on actually the first slides on the outline, we don't use lots of complicated data structure. And even I myself, when I do my jobs on the cluster, I even seldom use arrays, but we still mention that because it's kind of useful. But remember, Bash doesn't have too complicated data structure. It doesn't have too complicated variables for you, the schemes and mechanism for you to use, and not lots of difficult things for you to remember, especially for you just want to do your research, submit your jobs on the cluster. And I think the things we covered in the slides are enough. All right, so this is the first part. Second part, we'll talk about flow control. Basically, flow control is, first is judgment using if, and second is loop. It's quite simple. And if you have ever programmed a high-level programming language and these are not difficult for you to understand, and we'll basically go through those things through some examples. I don't want to go through every slide. The slides are there. You can read those slides at any time you want. I just want to give you some examples and try to understand those examples. And we'll talk about some particular things that Bash is different from you using other type of programming language like C or Python. Why it is so different, and we'll give some explanation. And that's why we have the tutorial here. Otherwise, you probably go to somewhere else, and you can go to online and search different shell scripting tutorials, but they are probably not meant for you to run shell on a cluster environment. All right, and the last one, the last part, if we have time, since we don't have too much audience, I think we should have enough time. We will just mention a little bit about advanced text processing commands, and basically grep, set, and awk. They are the three most useful tools that can greatly give you efficiency of your workflow under a Linux environment. And sometimes you do things like doing statistics over a table. And if you're a Windows user, you probably need to consult Excel. And that's not the way on the Linux. And you can find that when you are if you are comfortable with the text processing commands, that you will be doing these kind of things very efficiently using the tools we introduced today. And you can refer to more tutorials about these commands and after the training, because we just give a touch of it. But we just give a touch so that if you really want to learn more, and you can go search for advanced tutorials regarding these commands by yourself. Okay, so everybody have an idea about the things we are going to talk about during the 2-hour training today. So let's go to the first part. We'll give a general introduction to Linux shell. And this is the slides we have already used during the first training last month, which is the Linux architecture. And I circled the shell red, and the shell, you can see shell is an intermediate layer between the kernel and the applications, different type of user applications. So basically all the user applications, when you want to use them, you need to go through the shell. And shell is an interface between all these applications and the Linux kernel. The Linux kernel is the actual things, the actual layer does different work for you. Eventually all your commands, all your work, or your large fancy computational work are done through the Linux kernel. But the interface is through the shell. So shell is very important. How many of you using Windows or Mac? Okay. So basically Windows and Mac is a GUI interface, graphical user interface. The shell we introduced today is, on the other hand, it's a command line interface. So if you have, this is, let's go to the next slides. What is a Linux shell? The shell is a command line interface to the system. So the user, you type different commands, and the shell will interpret those commands and let it execute on the system. So here is, I think I copied it from somewhere. It's a formal definition of shell. You don't have to remember it. Just keep in mind, shell is a command line interface. It helps you to process users' commands and gather input and execute programs. And here in the slides, we also, I put on the slides, different type of shell. How many of you have already logged onto a cluster before or used Linux before? And most of you, you are using a new Linux system. The prevailing, the most popular Linux system today used is Bash. And that's circled here. And we will talk about our programming using shell scripting using Bash today. But I would also have to mention there are other type of shell with varied features. They do the same thing. They also provide command line interface, but with slight different syntax, grammar, slight different usage. The reason I mention these different type of shell, because most of you are graduate students or postdocs, professors. You start your work not from scratch. You join a group, and the group has already been using a type of job script for many, many years. You just need to add your own work to there. And those scripts might be written in a different shell, in C shell, in TCSH shell. So we have to mention that so that you don't get like completely lost when you see, oh, what is that? This is also can be another type of shell, but use different syntax. But they follow the same logic. Okay, so if you understand the bash, it won't be too difficult for you to understand the script for another shell, like C shell or TCSH. But we'll be focusing on bash. And its name is called a born again shell. You don't have to remember that. I never remember that. It's always bash. And this slide also compare the different type features. Compared to bash, you will see that it provides most features. So that's why one of the reasons why bash is so popular. You don't have to remember these things if you start, especially you're just starting from learning a scripting language, just use bash. And that's probably the one you start with when you first log on to any type of Linux interface nowadays. All right, so the next slide is what can you do with the shell? Basically, it's just accept user interface. So I am now on a shell. Let me see if there are any questions from the user side. Okay. Let's see, so I'm on a shell. The first time, let me first exit and start from the very beginning. I've logged on to Supermicro, which is the cluster with the most popular cluster. Do a clear, I can clear all the outputs. And one of the very first command I want to introduce is the type commands. Just give you some sense of how to use a shell. One of the first commands I want to use is echo $0. This is the command to tell you the current shell you're using. If you're using a CTCH or CSSH, if you echo $0, it will give you a different output. But here I use, since here I used bash, so it will give me the result of using bash. And I can switch to different shell. And first I want to check what kind of shell is available. So it's on the slides. Let's follow the slides. So basically we can switch to different type of shell by typing a CSH. Let's switch to C shell. If I do an echo $0, it will tell me that I am using a C shell. And that's very useful. And sometimes if you're executing a script, if you don't know what shell you're using, echo $0 will give you the result. Maybe you see why my commands are always failing. If one of the reasons is because you are using a different shell. All right, and definitely you can type different commands like date. You know, okay, what can we see here? We also provide compilers. You can, when you actually start to compile something, it's using the shell to invoke a compiler commands. But basically, the purpose of that slides is to tell you what we can do with a shell. And that's, you start different commands through shell. You interact with the shell instead of you're using a graphical user interface, clicking those buttons, drag and drop. And this is how we do things in a shell. This is the most efficient way of using the cluster, submitting our jobs. And we will introduce the graphical interface of HPC. And in after 2 hours, I think on March the 4th. And that's just provided another way of using the cluster. But it's the same thing, that what's underneath it is still the same command line interface. All right, let's go back to the slides. And the purpose of today is going to teach you how to write job scripts. Okay, on the what we will learn is the automation, the entire script of commands. It's not just the typing individual commands separately. We're going to learn how to make things happen automatically as you expected. Now here I also give some definition of shell scripting. A shell script is a bunch of commands put in a file, and the script is executed one by one line at a time automatically. And here, please pay attention to interpreted, not compiled. So think about compared to any of the program you're running, which is compiled as you run MATLAB. MATLAB, lots of commands that they are compiled. I don't know if many of you have programmed in C or Fortran. Think about it's compared to interpreted language versus compiled program. Which one is more efficient? Which one? Why? Of the shortness of the code, yes, but for speed, it's still for user-wise, you may find it's easy to use, but to interpret the language is inefficient when it is being executed. Why? Because you need an interpreter to interpret every line of your code, every line of your script. While the compiled language, if you compile C language and let it run, during the compilation, the code, your code is translated into machine language, machine code. When it runs, it's much, much more efficient than the shell scripting. And if you look at the second line, the majority of the scripts programs are quick and dirty. When the goal is to get a program written quickly, so it is not efficient as the program written C and Fortran and MATLAB. And that's something we will mention in the next slides. What to use, when to use shell scripting, and when not. I listed lots of things, lines here. When not to use shell scripting, select situation resource intensive tasks, produces heavy duty math operations, complex numbers, complex applications, extensive file operations, need native support of multi-dimensional array, need to use interface to legacy code. So what does this slides actually tell you? When not to use shell scripting. When not, don't try to do numerical simulation using shell. If you have a task and your advisor come in and I want a numerical integration of some kind of a complicated function, please don't try to implement that using shell scripting. Okay, it's a very, very wrong way to do. Don't do computational numerical simulations. Try to script with Bash or any type of shell scripting language. Okay, and you will learn why. You will learn why. Because Bash is not meant for that. It's meant for scheduled tasks. It's not meant for you to do heavy computation. Floating point operations is not even supported by Bash or any type of shell. It's not even supported natively. You need to consult some external program to do floating point operation. All right, so keep in mind, when not to use shell scripting, don't try to program, write a script, and do a computation of fancy, heavy, computational intensive tasks, like doing numerical integration or solving some kind of linear equation, system of linear equations, millions of orders of linear equation using shell scripting. That's a very, very wrong way to do. Okay. So far, anybody have any questions before we go to the next? We'll guide you through going through a shell script. So let's first take a look at a shell script example. And this is actually a script that has been executed each time you log on to Bash. And this is called a bashrc file, but it's actually a real case of a shell script. So you can see it is kind of not very difficult to understand. This is a give an example of what a real shell script, a bash shell script look like. It can have some control flow. This is source global definitions. It can also you can also define user specific aliases and functions. And actually here, and how many of you have already learned PASS and LD library PASS in our first introduction to Linux training? And we have mentioned that because these are very important environmental variables. You can also define some alias here, and that's easy for you to type some complicated commands, like submit an interactive job. Now, instead of if you feel this kind of a little bit intimidating, let's start from the very first hello world example. This slide shows how you write a hello world example. That's how we probably learn MATLAB, Python. The first program you write is hello world, right? Lots of things. The first thing you do to print out something, let the system do something for you, so you can have an idea of how it works. And so let's actually, this script only has 3 lines, and actually can be condensed into 2 lines. The first line is a special comment. Start from pound exclamation bin bash. This tells the shell which interpreter I use. Here we use bin bash to interpret this script. And the first thing is called shebang, hashbang, the pound sign plus the explanation. And any comment, any line start with a pound sign is a comment. So you can add lots of comment to make things, to let yourself know, let others know what you're actually trying to do. Add comments, add the necessary comments to all your lines. That's not only to make others looking at your work easy. It's mostly like to make yourself work easy. Maybe after 3 months, you go back and look at your own script. You have no idea what I'm writing about because you have forgotten it. So please add some comments to your own script to make it readable, more readable. And the next line is the echo command. Echo something. This prints the hello world to the screen. So it's fairly simple, and we're going to do it. I'm going to demonstrate it on our using C shell echo first, make sure I am using the bash shell, and I'm going to see the shell tutorial. And all these files are contained in the registration page. So you can download all the script examples after training and practice by yourself. We're going to first find the hello world. But this is exactly the same script we see on the slides. First, we have a bin bash. And second, we have comments, and then we actually do that thing. We print out hello world. So let me try to execute that. And the two ways we can execute this shell script. One way is to directly type /hello world.sh. Okay, when I execute that, it prints out hello world. Or you can use the bash interpreter. It's the same thing. But most of the time, I use // But when you use // what file permission is needed for this script? Please recall in the first introduction to Linux for the file permission part, which permission I need to give to this script. And what are the two permissions for a file? Do you still have that in mind? Read, write, and what? Execute. If you want to have the execute permission, you need to add the permission to that. If you forget that, please review the first introduction to Linux training. It has been explained thoroughly and how the different group of users execute that. But I know many of you attending this training are probably very new to Linux. So please make sure you have the execute permission for your file if you want to use the // way. Okay. Have questions? I saw many of you just looking at your laptop. I don't know actually what you have. You don't understand, you don't follow, or you really have questions that you want to ask. So if you don't understand, please do not hesitate to interrupt me because we don't have too many attendees today. So let's go to the next slides about interactive and non-interactive shell. So the interactive shell is that basically you can interact with the terminal. And non-interactive shell is when you run a script. So basically, when you run your job script, it is a non-interactive shell. And when you type commands on the terminal, it is an interactive shell. I here give a very formal definition because the explanation I give is not very rigorous. It's not a very strict definition. And even if you are executing a script by executing some commands like read, you can still interact with the shell, but it's a non-interactive shell, right? For example, I here give $$ is the only way. This is the only way how you differentiate an interactive shell with a non-interactive shell. If the output of your echo $- contains an I, this means you are in an interactive shell. If the echo $, the output does not contain the I, it is a non-interactive shell. And this is the only definition, the formal way to check it. And let me see. I here have a script. And this script allow me to interact with the shell because I want to have the input from the screen and I want to print it. I want to read something from the user input. I can still interact with the shell, but this will be a non-interactive shell. I put an echo $dash in here in this line, and let's do it. Check shell. It asks me to enter a value. I am running a script. This is a non-interactive shell, but I can still interact with the screen. I can type something, but after I execute that echo $0, it only output HB. It doesn't contain the I. That means in a non-interactive shell. So in simple, if you want to differentiate yourself with a non-interactive shell or interactive shell, the only way is to echo the $dash. Okay, so when you when you executing your script, it's non-interactive shell. Get confused or if you have questions? There are some fundamental concepts I want to throw to you at the very beginning so that for you to easy to understand the variables. There's one little bit confusing things for the variables, but if you understand these things quickly, it will help you to better understand it. Now here's another concept. The last slides talk about interactive shell and non-interactive shell. And next one is the subshell. What is a subshell? A subshell is a child process launched by a shell. So if you start another script, that script is being executed as a subshell to the current shell. A shell is an interface. We started another shell process. So when you start a script, this script is being executed in a subshell. And or when you type bash, it is start another bash process, and this is another shell. It's a subshell. So when I execute the script, this runs in a subshell of the parent shell. What is the parent shell? The current terminal process I am running. When I type a bash, this is another interactive shell I started. I can still execute under the current shell. When I type a bash, this starts another subshell and the interactive subshell. Have questions? All right. If the last two slides give you a little bit of confusion, and we will start the variable part of the shell so that you might get better understanding of these concepts. And I know these concepts give new users most of the confusion when they start to program shell. Why I don't see my variables? Why the variable of the shell? Why the variable in my script is empty? Why it is set to another value? The next part will be focusing on explaining the variables. All right, so we have finished the introduction part, and then let's go to the basics of how we operate on the shell. So how do we define variable? It's quite simple. Start with letter, underscore, cannot start with a number. It's case sensitive. And please do not use special characters. It'll give you an error because special characters reserve some other purpose. If you want to define a variable, directly run it. If you want to reference a variable, prepend a $sign to the name of the variable. So let's start with some easy stuff. I want to define a variable called myVar. myVar. And I want to give the myVar a value equal 1, 2, 3. Now, I define a variable. And the value of this myVar is 1, 2, 3. There is a very important thing. When you define a variable, I do not have any space before or after the equal sign. This can be confusing, but please keep in mind, when you define a variable, you cannot have space or tab before or after the equal sign. If I do this, it will say command not found. Do this will be command not found. Why? Because the space is used as a field separator of bash. So keep in mind, never when you assigning a variable, defining a variable, do not use space before or after the equal sign. It's very, very important. And it cost me 2 hours to figure that out when I first started my bash scripting. Okay, I have no idea what this programming language is about because bash is designed for that. Don't ask me why, because the space is an internal field separator IFS. So you cannot have space before or after the equal sign. All right, save you 2 hours to figure that out. And you cannot have the name starting with like, it's not allowed. You must not use the letter, use a number to start with a variable. And also if you want to variable at name, like 1, 2, 3, this is also not allowed. And if you want to reference a variable, use the $sign. Echo $var. Otherwise, if you forget about the $sign, it will just print out yours. The shell will interpret this var as just as a string, and just print out what it thinks it as. Okay. Now, the next slides has some connection about the subshell we talked about. That's the only thing that can be confusing throughout the slides, throughout all the about like 60 pages of slides. The only thing. So please, everybody, don't look at your screen. Look at this here, the demonstration, to try to understand it within 2 hours for this global and local variables. Actually, we have mentioned a little bit on this in Introduction to Linux, but since the past few semesters, people get confused about the global and local variables all the time. So I want to spend some time on that so you don't get confused. Global and local variables. Global variable, environmental variable, it's inherited by subshell. And local variable is only visible to the current shell as not inherited by the subshell. So first, put the two concepts, the two terms in your mind. One is the global variable, one is the local variable. The global variable are inherited by the subshell. So the subshell, when you execute a script, you can still use those global variables defined in the parent shell. However, if you define those variables locally, if they are not global variables, they are not visible, or you cannot use those variables in a subshell, in a script. Let's start with some examples. Now, let's clear. Let me first, to define a global variable, is use the export keyword. So in the last few minutes, I used name equal value. I am just defining local variables. In order for me to define some variables that can be used by subshell, can be used by your script, you need to use the export command, so they are visible for all its subshell. Use the export keyword. I highlighted in red. So let's actually do some exercise you can understand. Okay, let's use v1 equal 1. Now, how to print that variable? Using echo $v1. I reference that variable using a $sign. And it is 1. There's no problem. Now, I entered a subshell using bash. I started a bash process under the current shell. If I do echo $v1, what will be the output? 1 or nothing? Why? Because the v1 is a local variable and it's not only visible in the parent shell. It's not inherited by the current shell. The current shell is a sub-process. It's a subshell. Now let me execute. If I want the subshell to see my global variable, what do I need to use? How do I define that in the slides? To export, right? v1 equal 1. Now, if I do a bash again, I echo $v1, it's 1. So you should understand by now what's the difference between a global and a local variable. Now, I am currently in a subshell, right? Everybody still heads up. Please look at the screen. I want to do some different, not covering the slides. Remember, I here in a subshell, I echo $v1, and it is 1. If I export v2 equal 2, what will the output of v2 currently? What will be the output if I hit enter? 2, right? 2. Now if I exit the subshell, if I do echo $v2, what will be the output? That's what I did. How many of you vote for nothing? If it is not nothing, what will be the result? How many will vote for 2? It can only be the two answer. What, either nothing or it's 2. What is that? It's nothing. Why? Why it is nothing? Why it is not 2?
So we define global variable in a subshell.
Yeah.
Not in the main shell.
The parent shell, you define the global variables in the parent shell. And those global variables are only inherited by the subshells. It didn't say that if I define a global variable in a subshell, it will be inherited by the parent shell. It's one way. Okay, so if I define a variable in a parent shell, I enter subshell into subshell, it will still be visible because it's a variable from the parent shell. It's a global variable. However, if you define a variable, global variable in a subshell, it is not inherited by its parent. Keep in mind. And that causes confusion when users first try to write their scripts. Why it's empty? Why it is nothing? Because you define that in a parent shell. In a subshell, not in a parent shell.
How to tell whether you are in a parent? How to tell whether you are in subshell?
There's a shell level you can choose, but basically, if you are executing a script, you are executing a script under the current shell. So the current shell is your parent. The shell you are using for running your script is the subshell.
For instance, in your example, the parent shell was.
So let's go to the next slides. I understand why you're asking this, but actually, in reality, when we're writing scripts, it's not. We typically don't check the shell level. You can do a shell level. RVL. There's a shell level, I remember the value you used to choose, but I seldomly use that. In order for you to check if your parent shell, if your subshell is inherited by the current shell, it's only because you are executing a script. So whenever you are executing a script, think about it is something running under the parent shell. Check if the RVL is going to do the work. It's not. It's not the. There was a variable check the shell level, but we don't use that. It's a good question. All right. So let's first keep that in mind. And here is I prepared for a graph. A figure showing the global and local variables, the current shell and the subshell. When you define the global variables in the current shell, it's only inherited by the subshell. But when you define something in here in subshell, it's not visible. It's not inherited by the current shell. You can do the exercise, export var C equals something. And in the subshell, you can do export var S, subshell equals something. And you can do echo var C and var S. And when you execute the subshell, do the same thing again. See which one is still visible. And that's how you can get yourself familiar with the global and local variables. When you define something in the subshell, it's not inherited. All right, keep in mind. I think most of you already understand that this gives me a better because the last semesters, the people after I explain this, they still come in, nobody give the right answer. So I changed the way how I present this. So I think most of you have an idea about the relationship between global and local variable, right? Let's do another exercise to further explain that. So we do an export v1 equal 1, 2, 3, okay? I do a bash echo $v1. It should be 1, 2, 3, right? And I'll enter another level and do echo $v1. It's still 1, 2, 3. This is the second level. Second subshell is still visible for the parent shell defined global variables. And if I define something here, v2 equals EDD. If I exit, echo $v2, it's nothing because it's a global variable defined in the subshell. Even if I echo $v2, still nothing. If you define something in the subshell, it's not inherited. Now, there comes another question. If I have a script, in a script, I define some variables. After I execute a script, I want those variables still visible by this parent shell. Is there a way to do that? Since we cannot simply do it by typing execute the shell, right? If we simply execute that script, it's running in a subshell. So anything, if I even do export, those variables will not be visible by the parent shell. How do I do that? The right way to do that is using the source command. Right here, first look at the slides and we're going to give you some examples. Use the source command or dot. So if you see something dot and source, they are exactly the same thing. And people tend they seem to be reluctant to explain this, why they use this way. Source is the same way as dot. It does not execute that script in the subshell. It does not. It executes that script in the current shell. So if you define some global variables in the current shell, and those variables will be inherited because it's in the same shell. And let's give it an example. Should have a source var.sh. Let's take a look at this script. This is a script, a very, very simple script. I only have one line and export my var equal new value, okay? So let's look at this file and let's first execute that. First, let's do echo my var. First, I'll set it. Okay. Echo my var. No. Okay. Now my var is nothing, right? If let's do take a look at this script defines a variable in a script. If I simply execute that, if I do now echo $my var, what will be the output? Nothing or new value. If I execute now. So everybody is clear. It should be what? my var first, I print that out. It's nothing. When when I run it, after I run this, after I execute this script runs in a what? In a current shell or a parent shell? In a current shell, right? Or in a subshell? It's in a subshell, right? So in a subshell, I define the export my var equal new value. And now I am in the parent shell. What will be the my var? Nothing. Okay, if you don't understand, go back after the training, go back to the slides and practice these things again. This is the only thing I want everybody to have a clear understanding, which causes the most confusion. Okay? Yeah. It's running a subshell. Yeah. So keep that in mind. It's a subshell. It's the subshell of the parent shell. The parent shell is the terminal you at the first time you log in. When you run a job, it's the same thing. Okay? So how do I, if I want this definition to be effective, source this script. When I do source or dot, it runs the script in the current shell. It does not open a subshell. Now, if I do echo $var, $my_var, it's the new value we define. It's defined in the current shell. It's executed in a current shell. It does not open a subshell. Okay, this is the only confusion part, and I spent 20 minutes on it. Global local variables, how it is visible and how to inherit that. I hope everybody have a clear understanding of it. Even if you forget about everything, you need to at least know the difference between the global and the local variables, how the variables are inherited.
What about Q sub? If we have like stars?
Huh?
What about Q sub?
Q sub? Yeah. You Q sub a script, and when you run the job, that job will start a subshell. So it's run in the subshell. So keep in mind what variables are inherited. But that subshell is a little bit different. The variables will be initialized through your bash RC. If you define something in your bash RC, your job script will see those variables. So if you see a pass, LD library pass, those will be visible. Because what? You define that in the bash RC, and that's the parent shell of your job. Make sense? Okay, let's go to the next interesting part, quotation. Here are some of the environment variables here. Since it's listed on slides, I don't want to spend too much time explaining that. You can go through that. Hostname, PWD, ODT, PWD, and you just need to know them and remember them. And these are really very frequently used environment variables. There are other type of environment variables you can use, and you can do an env command to type all the environment variables, but we only list in the slides. Introduction is the very most frequently used ones. We have talked about the slide, the how to inherit the variables, and so let's talk about the quotation. Quotation is also an interesting part in Bash. There are three types of quotations: single quotation, double quotation, and backtick quotation. The single quotation is also called strong quotation. Double quotation, it is called weak quotation. And we explain why they are called that way. And I use these words, it's lots of other words. These terms are used to emphasize the functions of these quotations in Bash. Then the backtick quotation is different from the first two, and I will talk about that separately. Okay. So single quotation, every letter, every character surrounded by the single quotations are exactly as it will be interpreted. So anything between single quotes, it will be printed as it is. As a result, single quote cannot appear between single quotes. If you want to type something, type a single quote within a single quote, that's not possible. You can try to escape that, but that's not possible. Okay, let's just show the examples on the slides. On slide 20, we first define str1 is equal to echo $user. If I do echo $str1, everything is explained. If it's not explained, sorry, it will be printed as it is. This $user is we're supposed to print out the username of that, but it is just as it is because it's single quotes. Nothing is explained. Nothing is interpreted. This is called a strong quotation. Weak quotation. Let's first take a look at the definition. The weak quotation or the double quotation. Enclosing characters in double quotes. Preserve the literal value of all characters within the quotes with the exception of $, backtick, and slash. Backtick is backtick quotation, we'll talk about it later. $sign is used to interpret, reference a variable. And backslash is used to escape a character. So let's do str2. Instead of using the single quotes, we replace the single quotes with double quotes. str2. Now, please don't look at your slides and look at here. So you have thinking. If the slides have all the answers, then you stop thinking, okay? Echo $str2. What will be the result? As I explained. My username is fchen14. This is my username. What will be the result? Since I explained we are using double quotes, and double quotes will interpret the username. So username is what? It will be echo my username. All right. So it's actually not difficult. You just, whenever you want to print out some variable, use the double quotes. If you want to escape the $sign, add a backslash. Make sense? Because when I have a backslash, it stops to interpret the $sign. It's no longer referencing the variable. Okay. Now, the third quotation is back quotation, backtick. It's command substitution. So the single quotes and double quotes, they are just one difference between whether you can interpret those dollar sign with referencing the variable or not. For the backtick, it's just a command substitution. It allows the output of a command to replace the command itself, as I explained, we put on the slides. Enclosed string is kept as command almost the same as dollar bracket. And let's still give some example. So str3 is equal to backtick echo $user. Let's first try to do echo $user. If I execute echo $user, it will be my username is F14, right? If I do str3 equal backtick echo $user, what will be the content of str3? Think about it. Don't look at the slides, because when you look at the slides, it has the answer, and you stop thinking, and eventually you don't understand. What is in str3, and if I do echo $str3, what will be the result? It's command substitution. I will substitute the result of this command into str3. So what is the content in str3? And if I now echo str3, what will be the result? It's just my username, right? Because you understand it. Because it substitutes the output of this command. And the output of this command is F14. So if I print out that, it would be just my username. Please do some exercise at home so that you don't get confused. And the global local variables and the quotations are kind of confusion, but very frequently used things, elements in bash scripting. So don't get confused and make things clear. And because sometimes the backticks are so easily confused with the single quotes. Do you know where the backticks are on your keyboard? On my keyboard, it's something around this one. It might be different on some other keyboards, so it's not unique, but it's backtick instead of a single quote, okay? The single quote is something around my enter. I don't know where it is yours. They are different. So in order to avoid confusion, some people like to use dollar bracket. This is almost the same as the backticks. And this gives you the much less confusion. So I would prefer in my script, when I write something to my user, I use this syntax to avoid them confused with backticks. Surround that with a dollar bracket. Causes much less confusion. I said it's almost the same as backtick, not exactly. And in rare case, there might be difference, but that's quite way beyond the scope of our tutorial. So in most cases, I would prefer use dollar bracket. Right? Have questions? Pipe. Special character is the next slide, and we have actually explained most of the special characters. And just go back, look at the home. I seldomly want to explain a table that long in the training. So please just take a look at these, and we will explain most of the spatial characters through the examples. And here for the, let's go through that quickly. Pound sign start comment, $sign is reference a variable, backslash is escape, curly brackets enclose the name of a variable. And we'll use that when we talk about the arrays. Also, the semicolon is the command separator, and we show that when we talk about the control flow. And the dot command is exactly the same as source. So recall what does source represent? We just spent a few minutes on there. And also there's the pipe command and greater or less than, they are redirections we have actually talked about in the introduction to Linux. And also the process ID, test expression, integer expansion, and we will explain that in the next part about arithmetic operation. So let's talk about arithmetic operation. As I said, in the first part, introduction to shell, I said I use a slide to introduce when not to use bash for what? Yeah, don't try to do numerical simulation using bash. And we will explain why, because bash does not support floating point operation natively. You can use some external tools to use that. So first, let's try to do some math. It only supports integer math, okay? So let's try to do 1 plus 3, and let's do A equals 3, B equal 4, C is equal to C equal A plus B, okay? Then equal $C. 3 plus 4 is 7, okay? If I do B equal 4.6 and still use the command, it doesn't support floating point. Whenever you have a decimal places, it will throw in an error. I don't do floating point operations. Bash is not meant for that. Now there's another way. So the dollar plus the double brackets are using arithmetic operations, right? Keep in mind, this is a recommended way. There's an old way, like using this is called a parentheses, right? And if you do brackets, it's still, you can do that, but it seems deprecated. And $A plus $B. C is equal to that. Invalid arithmetic operator. Okay, because B is, I defined that 0.6, so I need to redefine that back into something integer like 5. Then it will let me to do that. So using the square bracket, you can still do it, but see, people don't recommend to do that. Use the first double parentheses. Okay, and also there's the let command. They can all do integer math, but they can only do integer math as well. C is $A plus $B equal $C. It's still the same thing. And keep in mind, Bash is very strict about spaces. So again, if you have a space, then it will give you an error. You cannot even have space between the plus and $B. In order, if you really want to add a space, you need to double quote it and do echo $C. Okay. There's also the expression command. I seldom use that. So preferred way is to use the double parentheses. And in some rare cases, you will have to, you think it will be great if I can do some floating point operations in math. In Bash, you can use the external calculator, BC calculator. So I probably want to do some exercises, 3.4 plus 5.6. I need to pipe it to external calculator BC, and it can still do that. And BC is the Bash calculator. This is an external calculator. It does not guarantee you have this tool. But you can, in most environments, in the HPC environments, you can use the Bash calculator to do floating point math. If you want to control the precision, you can use the scale equal 5 and do 2 as QRT 2. Spell it wrong, scale equal 5. And if you can give several digits, significant digits, because it scales 5. And this controls how we do the precision of the BC calculator. All right? I seldom do that. But sometimes it might give you some inconvenient way if you really want some floating point operations happening in Bash. And the next one is, so far we talked about variables, global local variables, and then we also talk about the quotes, and also talk about operations between the variables. And the only thing we want to touch is to use the Bash array. I seldom use Bash array, but since this is a programming language, scripting programming language, we still want to mention that. So how to define an array. The slides give us a couple of examples, so I just now demonstrated that. I define array, ARR, equal, use the parentheses to define an array. This actually starts as subshell, but I don't want to make it complicated. So AR, I define AABBCC is an array. If I want to print it out, if we want to print out the whole array, this won't do it. Because if you do not add curly braces, it will only reference AR, which is only the first element. To reference the array, use the $curly braces and ARR with the name of the array plus the curly @ sign within the brackets, and that's how we reference the whole array. Okay, AABBCC. And if I want to echo particular array element, it will use the number to reference that array, and note that the Bash array starts from what? 0. So it's the C convention. I think the same thing for Python, not the same thing for MATLAB, right? And also you can add some element to array. ARR1 is equal to, I want to define another array, and you can use here. If I want to print out ARR1, now it's simply just add the array elements after the ARR. Okay, and you can also delete an element and unset ARR1 3. And if you do echo AR1, and this just have that last element deleted. Okay, and these are in the slides. I just demonstrated that because the array, I don't think that's as important as the previous quotations, global local variables, and integer arithmetic operations. They are not as that important. So I just demonstrated that. For more information, for more detailed explanation, go to the slides. So we have finished the first part of the bash scripting. Next, we're going to talk about flow control. Since all of you have programmed a high-level programming language, the flow control we are going to talk about is only if, then else, and loop. We're going to give you some examples to show you how to use the flow control in bash. Let's demonstrate an example showing how we use the flow control in bash. And it's actually easy. So please don't look at your laptop as well. Please look at the screen so you sync with me. And we can understand how to use it together. So let me do some float control. I want to do A equals 3, B equals 5. I use semicolon to separate two statements in one line. A is equal 3, B is equal 5. Now, if I want to do an if statement, if $A is greater than $B, then echo okay, else echo not okay. And with the structure with an FI, it will print not okay. Why? Because 3 is less than 5. Quite simple, right? Everybody understand it? Now, pay attention to this. I am writing my judgment statement in here using square brackets. If I forget about the space, it will complain. So make sure you have space between your judge statement, if statement. Otherwise, it will complain. Let me change that statement. I want to make it a true statement, so I greater than do less than or equal to $B, and that will print okay because 3 is less than 5, right? What if I want to have multiple judgments, multiple if statements, multiple conditions? If my home directory exists, Not, it will print okay. If you have multiple conditions, separate them with brackets and connect them with an and. Some people want to write them in one statement. That's not going to work because Bash doesn't allow this type of syntax. If you do want to have multiple statements, condition statements, use enhanced test command, double brackets. That will allow you to put multiple conditions in the same statements. And if you can test if another statement fail, because this doesn't exist a home directory like that. So it will print not okay. Have any questions?
What is that? D?
Dash D means whether that directory exists.
Is it an existing comment or is it?
Yes, actually, we just write in that way. This there is a table in slide. Let's see if it.
I tried executing that in my shell in the Word says that minus D comment of not inside D.
Are you using our? Okay, I look at that after the training. Okay. So here, this is the file operation. This gives you a summary of all that. I don't want to go through that. I just want to give you a simple example. So if you want to see file is a directory, use -D. It's a regular file exists, a read permission, something like that. Okay. Questions? So we have finished the part for testing. And also, we want to talk about the next is for loop. There is also switch case, this syntax in Bash as well. And that is for a special pattern for Bash. It's included in the slides. And we also provide the example in the download material. But I don't want to spend too much time on that because if it's more frequently used. And let's talk about for loop. So the simplest for loop $sequence 1, 2, 3 echo $I. Okay, it prints out 1, 2, 3. This is a very simple loop for a variable in this sequence. Do echo $I, then finish it with a done. I write all the statements in the same line using the semicolon to separate these statements. This is just for demonstration. In reality, when you write your own script, please write them in separate lines to make it more readable. Okay, this is not a good way to write your for loop because this is for a tutorial. And I just want to everybody to while I'm typing, you can thinking so that I do everything on the terminal. In reality, when you write your own script, don't try to put multiple statements in one line. This is make your script very difficult to read, even for yourself. And this is demonstration for the for loop. And also let's do a while loop. So let's first read a variable C in a while C is greater than 0, do echo $C. Let's first do C minus minus. Remember what we do with the double parentheses is doing arithmetic operation. So C minus, and when we do echo $C, done. It first asked me to input a variable. I put a 4. And then y is still greater than 0, minus C, and print the C out. It's a very simple while loop. And also, you can Bash also provide an until loop. It's just simply opposite of the while loop. Just change the condition. So this is the way how we do while loop and until loop with for loop. For loop is the form most frequently used as if you want to loop through all the files in your directory, and that's we use for loop. Right? Okay, we have talked about control flow. So far, anybody have any questions? Are you getting lost? Are you getting lost? If you don't have questions, please still raise your hand. Okay. So we have demonstrated the control loop, for loop, until loop, while loop, and I also demonstrate how to do if statement. That's the control flow. We finished that within 10 minutes because I think it's until you have very complicated structure, these for loop and while loop should be sufficient for you to complete most of your tasks, schedule most of the tasks. And the last one is, the next one is about functions. Let's go back to the slides and talk about functions a little bit. Sometimes if you have a bunch of repeated tasks that can be finished within the same lines of code, we put them in functions. And the function is defined this way. First, you put a function name and put a parentheses. And note that this is just purely for parentheses. And put a curly braces to enclose all the commands used by the function. By default, all variables are local, are global. So it can be a little bit confusing if you have local variables unless you explicitly define the variables to be local. Right? So let's, if you want to pass arguments to the bash scripts, and then you just pass the the parameters after the function name when you call it, and you want to reference those variables arguments, use $1, $2, $3. $0 is the function name. So let's actually look at one example, function example. It might be a little bit difficult for you to understand that, but I here defined a function add, and I passed different command line arguments, $1 and $2, $A, $B to the functions, and go through that function add example by yourself when you're at home to understand how the bash add variables and how to reference those variables. Because we are kind of running out of time, I want to spend the rest to for the rest about 10 minutes. I want to spend it on the set and awk regular expression. All right. Okay, last one. Let's spend 10 minutes on the regular expression part with using grep, set, and awk. How many of you have heard of regular expression? Please raise your hand. Never heard of that. Okay, what does regular expression do? Regular expression for you to manipulate the patterns in the text. Basically, that's what the regular expression do, right? So let's go to the slides. The advanced text processing commands grep, set, and awk are, excuse me, supported, or mostly they are supported by the regular expression underneath it. So we use the regular expression to match a pattern of text. So they match pattern in strings, and then they can be to modify the strings. And different Linux might have different implementation of the regular expression. Sometimes it's shortened as regex. And there are some regular expressions that you can, examples, you can use how to specify the beginning of a string, the occurrence of a string, end of a string, and there are different relationship between those letters and strings. So we use the grep, set, and awk to match those patterns in the strings, in the text. Since we are running out of time, and I here have to mention the regular expression. If we don't talk about the regular expression in the shell scripting, it's kind of, we are actually not talking about shell scripting at all, but also it's a very long topic. And you do want to, you do need a lot of background. It can greatly enhance the efficiency of your workflow. And so we will give one simple example of operating on a table, which you might need to think about processing that with Excel, with a spreadsheet, if you don't have the regular expression. But we will show you a way how to process those texts using regular expression. And that is the way how we treat lots of different situations for the data and text files on the Linux. All right, so here's we first, I'm going to take a look at the original file, yes. Let me first move that. Take a look at this table. And this is a table, maybe I show the salary of some person in a company. And this table is commonly see, if I want you to add the total price, total salary of all these person, how would you do that? You need in a spreadsheet, right? Put everything in a spreadsheet and add them. But when you use grep, set, and awk with regular expression, it can be simply done on command line. All right, let's see how we do it. Let me first go to the examples. First, I want to select I want to select all the managers from the table. Okay, I use grep. I want to grab all the manager. What it does, it finds all the lines starting with man and print that line out. If I want to find all the employees with the title and with an ER, I also do that. It's very simple, right? And what if I want you to find all the employees' salary and add them? Basically, I want you to add this column. How do I do that? Without the help of an external program like Excel. We don't have Excel on Linux. And this command line interface, you don't have GUI. How do you do that? First, we find this line, we find this column with $500, 5,050, 500. We first want to remove the $ and a comma so that we can do addition. Okay, said I'm going to search for all the $ or comma. I replaced all the $ or comma and replaced with nothing globally, so that now this employee.txt is clear. We have all these clear numbers that we can add. This is actually does not change to the employee.txt. So I'm going to create. Now, if I do a cat employee.txt again, the employee.txt only contains the salary column without those $ and the the thousands separator, so that we can add. And the last tool we are going to use to add those salary is the awk. Awk is going to process each line as a spreadsheet and process them. And we are going to use a very short command to add all these salary columns in the employee.txt. So since we have that employee.txt available, we are going to do awk, do sum equal $fifth column is 1, first column, second column, third column, fourth column, fifth column, add fifth column. At the end, for each column, I'm going to sum the fifth column, which is their salary. And I'm going to print out the result to employee.txt. So one command is able to process all these records as we do in a spreadsheet to get the sum of employee.txt. So I kind of made a hurry for all these slides. It's just show you how powerful it is for you use the regular expression with the text processing tool to greatly efficiently speed up your processing workflow in Linux under a Linux text environment. And for more information, please search the tutorial of grep set.org. There are tons of information. It's not like 10, 20 years ago when I want to search for some information, I need to go to library. Everything is, you can go get it through Google. Okay, again, you can find those advanced tutorials of using the grep set.org. So it's now 10:56. I'm going to end today's training. And before we end, I want to do a short summarize of what we talked about today before we leave. We talked about basics of Linux shell. And we focused on basic of shell scripting. We talked about variables. Please recall yourself how to differentiate yourself between the global and local variables. And why they're confusing, because you have the subshell concept. And remember what is visible and what is not visible through a subshell, and how do you define a global variable, how you want your variables to be inherited in a script. And then we tried to do the arithmetic operations. And please keep in mind, bash is not to do what? Numerical simulation, okay? Don't try to do integration. Don't try to get a derivative using bash. It's a horrible way to think of that. And also we talk about flow control, and we also talk about functions. Flow control, we basically talk about if and different loops. We use an example for loop and while loop, until loop. And in the end, we introduced advanced text processing commands using grep set.org. They are based on regular expressions, and they will greatly speed up your workflow, especially you're processing lots of text data. All right. So basically, this is the end of today's training. So thanks a lot for attending. And please fill out the survey sheet before you leave so that we can greatly appreciate your feedback to us. And we will have a graphic user interface of accessing the cluster, which is using Open On Demand, which is scheduled the week after next, because next week is Mardi Gras. We'll have the Open On Demand tutorial on March the 4th, and hope you can all attend. Thanks a lot for attending. And if you haven't signed in, please sign in your sheet over there. We need to statistics for the attendance for our training to be continued. If you haven't signed in, please sign in your name over there. Thank you.